Welcome to Introduction to Quantum Field Theory, episode 25. In this, we will be covering a basic roadmap of classical interacting fields. There are three main forms of interaction within fundamental physics. The first is self-interaction, which is exhibited by gauge fields and scalar fields. And the second is Yukawa interaction, which is interaction between spinor fields and scalar fields. And the third is gauge interaction, where a spinor field can interact with a gauge field, or a scalar field can interact with a gauge field. Now, note that self-interactions here, so put a note, only occur. So self-interactions of gauge fields only occur with non-abelian gauge fields. Now, A mu, X mu is abelian, which means that there are no self-interactions in this gauge field. So A mu does not have any self-interaction terms. But we can see these self-interaction terms with scalar fields. So let's just give some examples for what things we will see in the future videos. So for scalar self-interaction, we'll have Lagrangians that look exactly like the Klein-Gordon Lagrangian. And they have the mass term. But then there's a new term, and I'll write this new term in pink. 1 over 4 factorial lambda, and then phi to the fourth. This right here, that is the self-interaction. So it is the field interacting with itself. So that's one thing we will explore in future videos. The next are Yukawa interactions. We have the Lagrangian, which will have the gradient of a scalar field squared minus 1/2 the mass of a scalar field squared times that scalar field squared. We can see that this right here is just this Lagrangian. So it's just you can say that this is scalar. Then we get the new terms, so plus I, we have a Dirac spinor, gamma mu, partial mu, Dirac spinor, minus m, but the mass that has to do with the spinor field, the spinors, and this right here, this is the Lagrangian for spinors. So we can see that so far the Yukawa interaction literally just is the sum of a scalar Lagrangian and a spinor Lagrangian, but it's also with an extra term. G is the coupling strength, and this right here, this is the Yukawa term. This is also something we will see in this video. Let's put this in pink just for consistency. And then we'll also look at gauge interactions. Gonna move everything on this up a bit. So you can also have gauge interaction. And I'm just going to write it down for the spinner gauge interaction because the same process is used for the scalar field. We have the Dirac. We have the Dirac. What do you call it? Right. We have the spinner. Um, spinner Lagrangian right here. So this is just the spinner Lagrangian. Then -1/2 partial mu a nu partial mu a nu minus partial mu a nu partial mu a mu. And this is the Lagrangian this is the Maxwell gauge. And then there will be one last term, which is plus E spinner gamma mu a mu here. And this right here, this is the gauge interaction term. So these will be the subjects that we talk about in this chapter, which corresponds to chapter 6 in No Nonsense Introduction to Quantum Field Theory.